So in the examples that we have done before, you have already seen a few instructions of the 8085 microprocessor. And here's the complete list. And you will find this sheet in the video description below. So as you will see, instructions are divided in groups based on the operation they perform. For example, we have the data transfer group, the arithmetic instructions, the logical instructions, and so on. And don't worry too much about all of these right now. All I wanted to do was show you the entire list so that you are aware that there are more instructions that this microprocessor is capable of performing. Here is how you will go about reading this table. In the first column, we have the opcodes. For example, it could be something such as move, and then you have RD, RS, which means move from source register to destination register. And we have already seen this instruction before, if you remember, move B, A, which moves the content of A into B. And then we have the number of clock cycles. This is the time it takes for the processor to perform this instruction. Next, we have number of bytes. So we are seeing that this is a 1 byte instruction. Remember, we said that each assembly level instruction is nothing but an English-like string which represents an equivalent machine code, and we need 1 byte to represent this 47, and that's why this instruction is of 1 byte. Whereas look at something such as this instruction, which is LDA, which means load into accumulator the value stored at this 16-bit address. So for this LDA, you will have 1 byte representation in the machine code, and we need another 2 bytes to represent this address. So remember, 8085 has 64 kilobytes of memory, and if you convert this number to decimal, it will give you 64 into 1024, which is equal to 65536, because 1 kilobyte has 1024 bytes in it. If you have 8 spots, you count from 0 to 7, and thus if you have 65536 spots, you will count from 0 to 65535. And if you convert this number to hex, you will get FFFF hex. And to represent each of these pairs, you will need 1 byte. And in the end, we have the actual instruction code which will be executed by the processor. And the way 8085 microprocessor reads this is in group of 4 bits together. So this one is 2 plus 1, which is 3, and this one is 8 plus 2, which is 10. And if you convert that to a hexadecimal notation, that is A. And thus the opcode for this instruction is 3A.